Welcome, boys and girls. This is Mr. Manise here with another mega exciting video, and this might be one of the most important videos that I have on my whole website, one of the most important videos that you might have in your entire mathematical career. I know that's a bold statement, but that's just the way that I feel about this. I'm going to show you guys how you can use your graphing calculators to check your answers on problems where the problem asks you to simplify your answer. So let's take a look at just a simple exponent example. Let's say we have x to the third times x to the fifth, and we say, okay, we add our exponents and that gives me x to the eighth. Now hopefully your teachers have taught you in the past to check your answer. I can just simply plug in a number. I don't know what x is. It's a variable. It can be anything. But somebody probably along the way has taught you, well, why don't we just plug in a number there? Why don't we just insert a 2 for x here and a 2 for x there, and let's insert a 2 for x here and see if both sides of the equation match. And that's perfectly fine. However, the problem with that is if you have a complicated problem, something like this, a squared, b to the 4th, c to the 7th, d to the negative 7 all over a third, b squared, something like this, it gets kind of complicated to remember, okay, I got to substitute a number for a, so I'll let a be 3, I'll let b be 8, I'll let c be 2, and then you just start kind of getting confused and forgetting what did you use for every letter, which number did you assign to each of the variables. So the trick that I'm about to show you with your graphing calculator eliminates all this stuff. Okay, now I will say, using this little trick of plugging in a number, you can certainly do that. You can plug in any number for x and see if the left side of the equation matches the right side of the equation. But the problem with that is there are certain numbers that you can't use that on. So say, for example, I have something like x times x. Okay, well that's x to the 1 times x to the 1, and that's going to be equal to x squared. Okay, the problem with that is you can't use the numbers 0, 1, and 2. Okay, well, why not? Why can I not use those numbers? Well, let's take a look. Let's insert the number 2. Let's let x be 2. So I'm going to insert a 2 there to insert a 2 there. Well, 2 times 2 is 4. So this side of the equation is 4. Let's insert a 2 on the right-hand side of the equation. Well, what is 2 squared? 2 squared is also 4. So we say 4 equals 4. Okay, good. That checks out. So I've done the problem correctly. But let's say that you made a mistake. And let's say that you said that x times x, let's say you added those and you said that's equal to 2x. Okay, well this is not true. That's not correct. X times x is not 2x. X plus x is 2x. But x times x is not 2x. Well, let's go substitute in a 2 right there, and let's substitute a 2 right there, and let's substitute a 2 right there for that x. 2 times 2 again is 4. And then on the right-hand side, 2 times 2 is also 4. So you're saying, yay, it checks out. However, all of your math was wrong. Okay, so there's certain numbers that you can't use, specifically 0, 1, and 2, and so you start having to use other numbers like 3, 4, 7, 10, or whatever, and you can kind of just get lost there. So this little trick eliminates all of this stuff to where you don't have to memorize anything. You let the calculator do all the work for you, and this is how it works. I am simply going to program my calculator to assign a number to every variable, to every letter. Now, if you'll notice in your calculator, all of the letters are in green above each of the keys on the calculator. So I'm simply going to assign a number to every letter. Now I just told you you can't use 0, 1, and 2, so I'm going to start with 3. So the way that you assign a number to a letter, to a variable, is you press the number that you want to assign, and then you come down here and you press this STO button. STO stands for store, and then you're going to assign it to the letter, and you have to press the green alpha button. Okay, so I'm going to start off with assigning 3 to the letter A. So I'm going to press 3. And then I'm going to press the store button, and then notice on my calculator it gives me the little arrow. My calculator is saying, okay, Mr. Manise, I got you. I'm going to assign 3 to which letter? I want to assign that to A, so I'm going to press alpha, press the green button. Notice my cursor is blinking A. That lets me know we're looking at letters here. And then I'm simply going to press the math button, which has the green letter A above it. So I press 3, store, alpha A, and then I press enter. Now I program my calculator so that it knows that every time it sees the letter A, it's going to substitute the number 3 for it. Okay, so I'm going to do the same thing for B. I'm going to press 4. I'm going to let B be 4. So I'm going to press 4, then press the store button, and then I'm going to press alpha B, and I'm going to press enter. So now if I just type in A, if I just type in alpha A, my calculator already knows that that's 3. If I type in alpha A times alpha B, my calculator already knows that that's 3 times 4, and so my calculator will spit out 12. It already knows what those letters are because I've assigned the numbers to them. So I know this is a little bit tedious. I'm going to assign a number to every letter of the alphabet, and I literally want you guys to do this with me on your calculator. So we've assigned A to 3, we've assigned B to 4, so let's do 5. So I'm going to go 5 store alpha C, enter. 6 store alpha D, enter. And we're going to go all the way to Z. And once you do a few of these, and you'll speed up and it'll get faster. So let's go 6 store alpha E, enter. 8 store alpha F, enter. 9 store alpha G, enter. You can pause the video if you need to slow down, that's fine. 10 store alpha H, enter. 11 store alpha I, enter. 12 store alpha J, enter. 13 store alpha K, 14 store alpha L, enter. 15 store alpha M, enter. 16 store alpha N, 17 store alpha O, enter. 18 store alpha P, enter. 19 store alpha Q, enter. 20 store alpha R, we're almost there, stay with me. 21 store alpha S, 22 store alpha T, 23 store alpha U, 24 store alpha V, 25 store alpha W, 26 store alpha X, 27 store alpha Y, and 28 store alpha Z. We made it. Lord have mercy, we made it. Now the cool thing about this is this will stay programmed until you either take the batteries out or reset the calculator to manufacturer's settings. So if you just turn the calculator off, if I turn it off and turn my calculator back on, then my calculator still knows that P is the number 18. And the cool thing about this is because you guys know on quizzes and tests, they throw J's and K's and P's and V's, and they don't just use X's and Y's. So now I have a number for every letter of the alphabet that they throw at me. Okay, so why do we do this, Mr. Renese? Well, here's the trick. Let's say that we go back to our exponent example, and let's say we have something like x to the third times x to the fourth, and we add our exponents, and we say that's x to the seventh. Instead of substituting a number, I don't have to do that. My calculator already knows that x is some number. X we've already assigned is 26. So all I have to do is simply type in the original problem exactly the way that I see it. Now X, there is an X button right here. X is the only one. You don't have to press alpha X. I can just press the X button here. So I'm literally going to type in the original problem exactly the way I see it. So I'm going to type in X. Now this caret button is the exponent raised to the third. All right, and then I'm going to press another X raised to the fourth. Now I will take just a second here. Some of you guys have the newer models that have the exponent. If your cursor is still up there in the exponent, you need to press this over button, press the arrow button so that you come down. It'll look like this. Your cursor will be up here, x to the third. Your cursor is still blinking up here in the exponent. You need to press the over button so the cursor drops back down, back to ground level there. Okay, so just depending on what kind of calculator you have. I have an older model, so my calculator has this old hat version. But anyway, I just want to point that out. Okay, so I'm typing in my calculator, x to the third, x to the fourth, and let's press enter. And guys, if you don't remember anything else I say in this video, remember this. When you're using this little trick that I'm showing you, I do not care what that number is. I do not care. It can be a decimal, it can be a whole number, it can be a negative number, it can be donkey. Okay, I don't care what that number is. I just want to make sure that this number matches what I think the answer is. I'm saying that x to the third times x to the fourth is equivalent to x to the seventh. Well, is it? So now I'm going to type in my answer and see if they match. So let's type in x raised to the seventh. Drum roll, press enter, bam, they match. That is so cool, guys. You can use this trick on any problem where it says the word simplify, simplify. Now, if I have an equation, okay, an algebraic equation with an equal sign, something like 2x plus 10 equals 12, okay, this little trick's not going to work. All bets are off. You actually have to solve this equation to figure out what x is. I'm only talking about problems where you have to simplify into the fourth times into the fifth times into the negative 2. Notice there's no equal sign here. The problem on the test, the quiz, is going to say simplify your answer. And I'm going to take all this stuff and I'm going to simplify it down to some other smaller, easier answer. And I just want to check that the original problem matches my final answer. In this case, I add the 4 and the 5, and that's 9, subtract the 2, and we're going to say that's equivalent to n to the 7th. Okay, so let's enter in our original problem. Now here I'm going to use n's. Okay, so on my calculator, I'm going to press alpha n raised to the 4th, alpha n raised to the 5th, alpha n raised to the negative. Now here's the negative button. Don't forget that. Here's the negative down here where my finger is. You got to know the difference between subtraction and the negative button right here. So don't miss that. N to the negative 2. I get some number, guys. I don't care what that number is. Don't care. Now let's type in what we think the final answer is. Alpha n raised to the 7. Drum roll. Bam. They enter. That lets me know I've done it correctly. Watch what happens if I made a mistake and I didn't subtract the 2. What if I added 4 plus 5 plus 2 and I said my final answer was n to the 11th? Now watch what happens. Now when I type in my answer alpha n raised to the 11th, now notice that this number is different. This number is different than the original problem. So if it's different, that lets me know, hey, I've made a mistake. I got to go back and find my answer. And this is a great way. Guys, you can't just use this trick in just exponents. You can use this in algebra, advanced algebra, geometry, college classes. I used this trick when I was in college. I mean, this is not just a one-time thing. You can use this for any problem that says simplify, okay? So let's look at some more examples, and I'll show you what I'm talking about. Let's take a look at something like, let's do a couple more exponent problems. Now, I'm not going to go through and show you how to work all these problems. That's not really the point of this video. I got other videos to show you how to do it. This video is just geared toward checking your answer versus the original problem. Let's say we start off with an exponent problem like this. Negative 3x squared. And guys, please pause the video if you want to slow down. Please pause the video and rewind it if you want to slow down and do these over and over and over. So let's say I got negative 3 x squared, y to the third, z to the fourth, all raised to the fifth power. Okay, that's a 5. I'm not going to go through and simplify this, but let's just say that we think the answer, the simplified answer is negative 24, negative 243, x to the 10th, y to the 15, z to the 20. Let's say that's what we're going to circle on our test and our quiz. Okay, I'm going to type in exactly what I see here on the calculator. I'm going to literally type in the parentheses, and I'm going to use the negative. That's a negative 3. Negative 3. I don't need to press alpha x. There's an x button. I don't need to press raised to the second because there's also, if you can see my finger here, there's also that little squared button. So I don't need to press the little caret button. I can press the squared button and that's fine. Anything else, I'll need to raise it to the power. Okay, so I got negative 3x squared. I've got y to the third, so I'll press alpha y raised to the third, and I got the z. Alpha z raised to the fourth. I need to close the parentheses here. You got to do that. Close the parentheses, and all of this is being raised to the fifth power. So I need to do caret raised to the fifth. Do not care what this number is. We got a negative 8.9. That's fine. Don't care. Let's type in our answer, okay, and see if they match. So I type in negative 243 x raised to the 10, alpha y raised to the 15, alpha z raised to the 20, press enter, bam, they match. I get a grin on my face every time that happens. Guys, when I'm doing the answer key, I'm the math teacher. I can do all this stuff. But when I'm making my key, I check. I use this trick to check my answer to make sure that I didn't make a mistake. We all make mistakes. You make mistakes, I make mistakes. This is a great way to check your answer to make sure you're catching all those little sign mistakes. A lot of you guys have trouble with signs, positive and negative. Let's say you forgot that a negative raised to an odd power is a negative. Let's say you forgot that. And you put your final answer as positive 243. Watch this. Positive 243, x to the 10, y to the 15, z to the 20. Okay, I get a positive number. I say, uh-oh, wait a minute, they don't match. I did something wrong. Something's wrong. Okay, let's look at another one here. Now, this is the one thing I do want to make sure you guys have a good handle on is an example like this. What if I have negative 11r to the third power, s to the 8, t, all over negative 44, r to the negative 2, s to the 11, t to the fifth power. Again, I'm not going to go through how to simplify this. Let's say that we think the answer is r to the fifth. It simplifies to r to the fifth over 4s to the third, t to the fourth. Okay, that's what our final answer is. Okay, so I'm going to plug in my original problem. Here's what you guys have to understand. You cannot just type in divided by negative 44, r to the negative 2, s to the 11, t to the 5, because your calculator will see that as multiplication. You must, if there is more than one thing in the denominator, I've got several things in the denominator. If there's more than one thing, guys, you must put this in parentheses. I must put the denominator of my final answer in parentheses. So it looks like this, negative 11 alpha r raised to the third, alpha s raised to the 8, alpha t raised to the, that's just raised to the 1. Okay, now divided by, I must put this in parentheses, guys. Parentheses negative 44, alpha r raised to the negative 2, alpha s raised to the 11, alpha t raised to the 5. I must close the parentheses. I get some number, don't care what the number is. Let's enter our answer. Alpha r raised to the 5 divided by parentheses 4 alpha s raised to the third, alpha t raised to the fourth. Close the parentheses. Bam, they match. Yes. I know I've done it correctly. Okay. So those are some examples with exponents. But like I said, guys, this pertains to anything. What about radicals? What about if I'm simplifying radicals? Let's say I have something like the square root of 75. I don't even have any variables here. Okay. If I want to simplify the square root of 75, again, I'm not going to go through how to set this up. Okay. This is actually going to simplify to 5 times the square root of 3. Okay, so we're saying that the square root of 75 is equivalent to 5 square root of 3. Well, let's check it. All right, the square root symbol is right above the x squared button in blue, so anything in blue I have to press the second button. So I'm actually going to press second square root 75, close the parentheses, I get some number. Fine, 8.66. Let's enter our answer. 5 times second square root of 3. Bam, they match. So that lets me know I've done it correctly. Okay, what if I have a, let's say I have a cube root, something like this. Let's say I have the cube root of, say, 16, and we think that that is equivalent to 2 times the cube root of 2. Okay, so now I'm going to press the cube root. The cube root button is, I got to press math, and I got to select option number 4. The cube root of 16, close the parentheses to get some number. Now let's type in our answer. 2 math cube root of 2. Close the parentheses, bam, they match. That lets me know that my final simplified answer does indeed agree with and match the original problem. Okay, let's look at some simplifying some radicals with some variables in there. Let's say I have something like, let's go with the square root of 32 x to the 6th y to the 5th. Okay, again, you would break this down into perfect land and non-perfect land. Again, I'm not going to go through how we actually simplify this. Let's just say that we think our answer is 4x cubed y squared times the square root of 2y. That's what we think the simplified answer is. Okay, I'm going to type this into my calculator. I'm going to type in second square root 32x raised to the 6th, alpha y raised to the 5th, close the parentheses, get some number, don't care what that number is, let's type in our answer. 4x raised to the 3rd, alpha y squared, I'm just going to press the square button, and then times square root of 2 alpha y, close the parentheses, bam, they match. That lets me know I've done it correctly. Let's say we forgot the 2. Okay, that's a common mistake in this kind of problem. Let's type in our answer. 4x raised to the 3rd alpha y squared times just the square root, square root of alpha y. Uh-oh, they don't match. That lets me know I've done something wrong. Okay, let's look at, this pertains to polynomials. Let's say we're adding polynomials, combining like terms. Let's say I have something like this. Negative 3x cubed plus 2x minus 17 minus negative 4x cubed minus 6x plus 1. Again, I'm not going to go through how, let's say that we thought that the correct answer was 7x cubed plus 8x minus 18. Okay, let's type in the original problem. Negative 3x raised to the 3rd plus 2x minus 17 minus a negative 4x raised to the 3rd minus 6x plus 1, and we get some number. Okay, fine. Let's type in our answer. 7x raised to the 3rd plus 8x minus 18. Now, I purposefully made a mistake on purpose. Negative 3, this would become a plus 4, but I made a mistake, and I added, and I got 7. So you're going to see, uh-oh, the numbers don't match. I made a mistake here. That's a negative 3x plus a 4x right here. Okay, this should have been a single x. So now I can find my mistake and go back and say, I found my mistake. X raised to the 3rd plus 8 x minus 18. Now they match 17,000 and 17,000. I found my mistake. That is such a nice trick and resource to be able to have. All right, let me do a couple more real quick. This could pertain to foiling or factoring. Let's look at using the FOIL method. There's no equal sign here. Notice there's no equal sign in any of these problems. I'm just simplifying. Okay, you're likely to see this on a test or quiz or on the EOC. How do I do this? FOIL first, outside, inside, last. Again, I'm not going to go into specifics for how to solve this. So let's say that we think this simplifies to x squared plus x minus 12. Okay, let's check it. I'm going to type in exactly what I see with the parentheses. Parentheses, x plus 4, close the parentheses, open the parentheses, x minus 3, get some number. Let's type in our simplified answer, x squared plus x minus 12. Drum roll, bam, they match. That lets me know I've simplified it correctly. What if I am factoring? What if I am going backwards? X squared plus 3x. This will be later on in the curriculum, in the geometry curriculum. What if I'm factoring this? I'm looking, what are the factors of negative 10 to add to 3? I say, that's going to be positive 5 and negative 2. So that's going to factor is x plus 5 times x minus 2. Did I factor that correctly? I'm not sure. Well, let's check it. Let's type in the original problem. X squared plus 3x minus 10. Get some number. Let's type in our simplified answer. X plus 5, another parentheses, x minus 2. Man, they match. How cool is that? So guys, take a few minutes, go back, slow it down, rewind, watch this video again, because like I said, I think this is the most important video that we have in the whole, on my whole website, maybe that you'll have in your mathematical career, because checking your answers is so very important. So anyway, I hope you guys enjoyed this, and we will see you on the next video.